Hey everyone, in this module we are diving into version control. Version control is one of the most important aspects of being a software engineer. It touches everything you do, it is everywhere you are, it does so much for you. I have heard version control likened to the pen or the pencil for the artist. So it is just an essential tool. And it is understood that you know what this is and how it works and you use it on a regular basis. So we got a lot of great resources here for you. And I think you'll pick up a lot of great things. So first off, what does version control do? You create a repository to keep code. You can check out copies of code. You can check changes back in. You know who changes what. You can branch and tag and do all this fun thing and roll back changes. But I do want to be clear at the beginning. There's some things it does not do. It doesn't compile code. It doesn't test code. It doesn't think. It isn't make sure your code is readable and well written. It doesn't do crazy things for you. All it is a tool to track what you are doing, how you are doing it, and to manage the flow of development between one or more developers. With that being said, I want to show you all a quick overview of some things and then push you on to some great resources and videos that you can check out. First off, we have this thing called local version control. Many of you have done this. I have done this, where you may have a version database or something like that. Normally, this happens when I write papers with people that use Microsoft Word. We end up with a long list of Word documents that have V1, V2, V3, or the date at the end of each file change with somebody's name. So we are versioning those files so we know who made the changes, what order they go in, and can go back and look at all the different changes. This is how we do it locally, right? We just have a version database. Maybe that's a folder. You can check out a file, check it back in so people know you're working on that file, and it works like this. Right? So this is just locally. You can also work in what we call a centralized version control scenario where you have your working copy locally and you have a remote repository. This is an old school model. This used to work with RCS, CVS, SourceSafe, Subversion. Subversion has since updated its methodology, but basically you would have a remote server or a website or something that held the code, and you would get a working copy. And whenever you wanted to work, you would check out a file, and that would lock that file so no one else could make changes. And then you would commit that file. You would commit those changes. You would push them out to that remote repository, and then you would pull updates that other people had sent in. Right? But we have the newer model and the more common one in industry now, which is distributed version control. That's where we have a repository on the server. And when you work on that repository, you don't work directly with the remote repository that's listed in the server right here. That's just not what you do. Instead of doing that, you make a copy or a clone of the repository as a whole, and then you work on it locally. So we will be using Git in this class. So what you will find out is you have a repository on the server. Locally, you have a folder, and most of the time when you are in that folder looking at the files, you are actually working on the working copy. And when you use version control, you are adding updates and information to the repository, which is stored in the .git or .git folder. Okay? This is the modern method. Git, Mercurial, Bitkeeper, all these work this way. Here's another view of this, so you see. This is what Git actually looks like. We have a remote server with our remote repository. We have a local repository. We have our working copy, which is actually our files. And then you'll see we have this index or staging area. We can check out files from either the local repository or the staging area. You can add files, right? Adding just means telling Git or the version control system to pay attention. You can commit those files, which means actually storing an official snapshot of where things are in the local repository, and then you can push those changes out to remote. And this is a cycle that completely repeats itself, right? So you will find that you will end up in this cycle where you initially clone, and then you add, and then you commit, and then you add, and then you commit, and then you add, and then you commit, and then maybe you check out, and then you add, and you commit, and then you push your files, and then you pull the changes that other people have made. So you can just go around this diagram, and these are actually almost verbatim the Git commands. Another view which shows you what Git looks like. The workspace or working files, your index or what's being tracked, your local repository that's stored in your .git folder, and your remote repository. So there's lots of things here, right? So I can commit files. I can add and commit files. Add just means you're telling Git to pay attention to a specific file. You can push changes from your local repository to your remote repository. You can pull changes all the way down into your workspace, which also pulls those changes into your local repository. Or you can just fetch changes, which means don't change what I'm working on, but store the new changes in my local repository for me to work with later. We can revert things through checkout, revert, and reset. We can also work with diffing, or seeing the difference between our current working code that's in the what's in the index and what's in the local repository. So please remember here, I know this feels like it's fast and it's crazy. Review this video a couple times, but I'm going to point you to many more resources. You actually have a lot of videos to watch this week to catch up that are well made, and other ones made by me. A few key concepts I really do want to point out to you, though, are things like branches. When you're looking at a Git repository, we often use this visualization. Every one of these dots is a snapshot of where your code was at that point in time. This line going right down the middle is considered the master branch. Okay? The master branch is it's the main branch. It's where you do most of your development. Sometimes we want to try some things. We want to experiment. We want to work on some things that might damage the code base or interfere with things other folks are doing. Or we may just have that defined as our workflow. So we will do things called creating branches. So what that means is I can create a branch of code that is different from the master branch and work on it and make my own commits. I can also switch back and forth between these freely, right? And eventually I will merge these back together. The branch command is git branch, right? That lists all the branches. Git branch with a name will create a new branch. You can do git branch minus D in the branch name to delete a branch, right? Also minus D, and you have minus M to modify a branch or move a branch to a new name. There's a lot of things that go on with branches. This is one example of this workflow where you might have a little feature, you might have a big feature, but this is always the master branch, just like I talked about. Okay? To get to another branch, you type git checkout in the existing branch's name. If you do git checkout minus B, that will create a new branch, right? In this case, it would be named new dash branch. You don't need those arrows on the left and right side. Okay, that's all just a placeholder. But you do git checkout minus B with a new branch name, and that creates the branch and switches you to working on that branch. You can also do create a branch off an existing branch by using this syntax. Once you're done working, you will obviously merge those changes back in. Merge always merges into your current working branch. So if I would say git merge a branch, it would merge it back into where I currently am. You can also do this with no fast forward. So we do have multiple types of merges that we will talk about at some point here. There are three-way merges, there are fast forward merges, and there are rebasing. As an example, here is the master branch right here. And this goes up and we branch off to develop some feature. When we merge, right, and this is a fast forward merge, you'll see those commits get pushed together right here. So some feature and master are both in the same location. This may be a little different where we have new commits on master and we have our commits on some feature. When we merge here, we get what's called a three-way merge. The major difference between a three-way merge and a fast forward merge is that here we have not created a new commit. We've literally just replayed these commits on top of the previous commits. Down here, because the timeline crosses over, you have to create a new commit called a merge commit that tracks everything. Okay, so in short, those are the high points. I have lots and lots of links here for you to check out, so you can check those out. They're also inside Canvas. The other thing I want to talk about is workflows. There's different ways to work with Git. The first way is centralized. You treat it just like there is a centralized repository. You all push code back and forth. And that's old school. Generally, we don't do that anymore. The other type is called feature branch. In feature branch workflows, what you do is you create a branch for every feature you work on. Once you complete that feature, you merge it back into the master branch. Okay, that tends to look something like this. And then we get onto something more involved. So this is Gitflow. Gitflow has a master branch. It actually has multiple branches, right? So you'll see this branch out here has versions with tags. There's lots of stuff. So what we do is we have our master branch, which has our release versions with tags, and we have a development branch. But we do all of our work on that development branch. So whenever we have a new feature, it always branches off of development. Well, then we take all that and we merge it back into a release branch. So master, development, features, release, and then release gets merged back into master for release. We may also end up with things called hot fixes when there's bugs in old versions and things like that. And we'll actually roll back, check out the old version by tag, create a new commit, and merge that back in. This can get very, very confusing. A lot of people really love this because they feel like it keeps it very organized. It creates some cool charts and graphs and GitLab and GitHub and things like that. So some people like these. There are different types though. For instance, Google doesn't use Gitflow or feature branch. They use trunk-based development, which is a whole different methodology. So there's a lot of these. The truth here is that you just have to know what you're using and how to use it and how it works. One other thing you can do is you can fork repositories. Forking means that you make a new copy. So if you were on GitLab and you forked a repository, you would get a whole new copy of that repository right under your own username in its own workspace. The cool thing about forking is it always tracks back to the original project, so you can ask for a merge request to put your changes back in. That being said, if you look at the Canvas site, you're going to find this page, Git and Version Control Resources. You really, really, really need to watch the whole Git series by Blade Frisch. Watch my series on Git, GitLab, and version control. And then browse through the rest of these resources. There's some really good ones here. They'll explain a lot of this stuff that I have talked about in much, much deeper context and content, because I just wanted to hit the high points and give you an overview. So I hope you are well, and we will talk to you soon.